Next, let us look at the reciprocity theorem. What does the reciprocity theorem says? The reciprocity theorem says that a circuit will be reciprocal. What is the meaning of reciprocal? That I will say later. Anyway, right now you just understand this, that the circuit will be reciprocal if the circuit is uh, linear, then bilateral, then active, and single source network. Single source network. So let's see one by one. Linear means it should not have any nonlinear device like diode, transistor, or anything. So this circuit is linear, no problem. Bilateral means it should be able to transmit current in all the directions, both the directions, and which is happening in this circuit, no problem. It should be active, that means it should have a power source, which we are having here, and it should be a single power source, which again we are having here. So this circuit is fit to be a reciprocal network. Now what is the meaning of reciprocity? For understanding reciprocity, you can look at these two diagrams that we have drawn. Here I have marked 20 volt and the current I in different color. Why? Because this 20 volt is the source because of which this current is happening. So in a way, this is the source and this is the response. Or you can also say that this is the excitation or input. Excitation, and this is the response. Now what a reciprocal network means is, whatever is the response that you get with this excitation, if you interchange their position, like what has happened here. What did I do? I took this 20 volt, I put it in place of I, and I took I and I put it here and I named it as I dash. What reciprocal network means is, this 20 volt will produce a current I, and this 20 volt will produce a current I dash, and the circuit will be reciprocal if I and I dash are both same. So let us verify whether it is same as it has been asked in the question. So we will do away with all the tick marks and let us start. So yeah, so here I want to find out I. You can see that I will be because of this, let's name it as IA, and IA is basically 20 divided by 10 parallel with 6 plus 4 is 10 plus 5. 10 and 10 parallel will give me 5, so 20 divided by 5 plus 5, which is 10, so I will get IA is equal to 2 amps. That IA is getting divided into two branches. According to current division rule, I can find out I, which will be IA multiplied with the multiplied with the current division rule, which is opposite branch, which is 10 divided by the total, which is 10 plus 6 plus 4, which is 20. So we can say that this will be 2 into 10 by 20, which comes out to be 1 amperes. So I is 1 ampere. Now let us look at this circuit. Here again, see, you can use this particular method of doing like I have done, basically current division rule, because actually there is only a single source, as we have told. Most of the time it will be single source, so there is no need of doing mesh. But that does not mean that mesh won't work here. You can actually write this as IA I and then do the mesh analysis and find out the value of I. Still you will get the answer of I as 1 amps. Anyway, now here if suppose I am going to consider this as, let's say, IB, then I can say that IB will be equal to 20 volt divided by 5 parallel with 10 plus 4 plus 6. So that is 20 divided by 4 plus 6 is 10, and the parallel value of of 5 parallel 10 will be 3.33, from which I will get the value of IB is equal to 20 divided by 13.33, and that I can actually find out 20 divided by 13.33 and get the answer as 1.5, or I can just leave it like that and then straight away use it to find I dash by current division rule. Now this IB is going to be split up into two portions. So I1 will be IB, which is 1.5 into the current division rule says opposite branch, that is 10 divided by total, which is 10 plus 5, which is 15. So 1.5 into 10 by 15, which is actually 1. So you have got I dash also 1 and I also 1. So we will say that the current remains same even if we have interchanged the excitation and the response. So that is how you do a reciprocity theorem verification. So you will be given a circuit like this. You have to find out what is the excitation, which will be a source. It can be a current source, it can be a voltage source. Response will be what they have asked you to calculate here. So here the response is I. Why? Because they have asked you to calculate I. So when we do reciprocity, we have to do one circuit in which this same arrangement is there, and in the second circuit the I basically comes here, or the if whatever is the response, it comes here, and the voltage source, it goes there. Now you can have a similar situation where they may have, like, let's take for an example another circuit where it may be a current source of, let's say, 2 amps, and then there is a 5 ohm resistor here. Same circuit, I am not drawing anything else, I am drawing the same circuit, and 4 ohms, and like you can have I, but instead of I, suppose they will say calculate the voltage across this, so they will say plus minus V, and this is 6 ohms. So now in this case, this is going to be the source or the excitation, and this is going to be the response V. That is going to be the response. How do you interchange them? You draw the circuit by just drawing 6 ohms here and trying to take V across 6, and 5 ohms here, 10 ohms here, 4 ohms here, and in this place of 6 you straight away draw a current source of 2 amperes value. And if the circuit is reciprocal, then this voltage that you are getting here and this voltage, let's say V dash, that you are going to get here will be same. That is reciprocity theorem. The same can come for a AC circuit also.